right, so we just looked at truth tables for different statements, and if you noticed, when we got to the last column, the final culmination, the whole statement itself, most of the time we saw a smattering of both true and false in that last column, okay? And that's often the case, but it kind of begs the question, is there ever a time when we would find that the statement is true in every case, or maybe the statement is false in every case? And the answer to that question is yes, there are times that we will find that that happens. So we are going to look at the simple statement, I'm going to Italy in June, and the negation would therefore be, I'm not going to Italy in June. And now we're going to look at these two statements. I'm going to Italy in June, or I'm not going to Italy in June. Okay, that first statement, the one that I just highlighted there, that one is always true. Okay, and when I say that statement, I mean the whole thing. Either I'm going to Italy in June or I'm not going to Italy in June. There's no way that can be false. Okay, there's either I'm going or I'm not. Okay, those are the only two possible options. Now, the second statement, I'm going to Italy in June and I'm not going to Italy in June. That one is going to cause problems in the other way. That statement, no matter what, is always going to be false. Okay? You can't go to Italy and not go to Italy. That's just not the way it works. Okay? So, we have some special terms for that. When the compound statement is always true, it is called a tautology. Okay? Think of it as total, but spelled completely wrong. Okay? A tautology. And then when the statement is always false, it is called a self-contradiction. Okay, which kind of makes sense. If you're like, hey, I'm going to Italy, but I'm not. I am and I'm not. Those are contradictory. That's a self-contradiction. So again, those two phrases sort of make sense. So what we're going to do here is we're going to work through each of these different statements, and we're going to see if there is a tautology, if there's a self-contradiction, or if it's neither one. Okay, so just as a reminder, a tautology means that you are completely true all the time. A self-contradiction means that you end up always false all the time, and then neither is kind of a combo of the two. Okay, we have trues and falses all together. So looking at our statement here, I'm going to just take the first set of parentheses as the first thing I'm going to look at. So I'm going to evaluate P or Q. All right, so P or Q. Remember, only one of them, P or Q, has to be true for the statement P or Q to be true. And so we've got true, 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 and then false. Okay, so that takes care of this portion right there. The next thing I'm going to go ahead and look at is the next set of parentheses, and I notice we have a negation in there, a not P. And so what that does is it takes all of the values of P, all of the truth values, and changes them to the opposite. So now that little bit is done. And then I can take that last set of parentheses entirely and do this one. So again, we're looking at the not P implies Q column. So not P is this column right here, implies Q. So false implies true. That is true. False implies false is a true conclusion. True implies true is a true conclusion. True implies false is a false conclusion. And then last but not least, we're going to put the two halves together. So we've got P or Q and not P implies Q. And so we're going to be looking at our P or Q column and our not P implies Q column. And for an and to be true, remember both statements have to have true as their truth value. So we've got a true, a true, a true, and a false. Oops, forgot to switch my pen color back. All right, so in this case, is this a tautology, a self-contradiction, or neither one? This is going to be a neither one. because we've got a combination of trues and falses in that last column. All right, moving on to question B. So going through again and looking at what we've got, taking that first set of parentheses there, we've got a not Q. So again, we're just going to switch the truth value of the Q column. Then I'm going to take the parentheses, so P and not Q. So P, this row here, and not Q, both of them have to be true in order for the and statement to also have a true. So we're going to have false, true, false, false, based on those first and third column. Okay. Now this whole section is done, so the next thing I need to do is negate P. So switching the truth values of the P column. And then last but not least, again, I can do the whole thing. So P and not Q and not P. And so again, taking a look at the columns I want to use P and not Q and my not P. Remember that both of those would have to be true in order for the and to be true. And I don't have any where I have a true and a true. So we have a false, 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 false. And so in this case, because they are all false, this is a self-contradiction. Okay, and then what I would encourage you to do is go ahead and pause the video for the next one, fill out the truth table yourself, and then see whenever you get done if you can match what I have on the flip side. All right, so there is the finished truth table. Again, just make sure that for your P implies Q, the only one that's false is a if true, then false. That's false. And then for your or, again, all you need is one or the other of the two statements to be true in order for the or statement to be true. So this is one where we have all things have come out to be true, and so this one is a tautology. All right, that's the end of this video. Again, just looking at self-contradictions and tautologies.